First, download the Apache Storm from their wiki website and extract it to your local directory. Once done, first thing we need to do is to change the configuration file to update the details of Storm topology. Let's now open storm.yaml file. Modify the path to Storm's local directory where Storm saves its intermediate files. Also update the details of the Zookeeper server. Similarly, modify the details of Nimbus and update the port of Storm UI. Here we're specifying the Storm worker node details. We can leave other configurations default. We can see there are 4 worker nodes specified. Once the changes are done, save the configuration file and let's move on to configuring Zookeeper. Download the Zookeeper and extract the Zookeeper in a local directory. Let's modify the zoo.conf file to update the Zookeeper's data directory path. This is the path where Zookeeper saves its local files. We can leave the other configurations default. Once the configurations are saved, let's start the Zookeeper. The Zookeeper has been started now. Now let's start Nimbus and supervisors in a similar fashion. To start this Nimbus, we can use the storm command with the argument Nimbus. It may take a while to start, so meanwhile we can start the supervisor node in the similar fashion. Use the same storm command with the argument supervisor to start the supervisor. Storm also provides inbuilt support for UI, which also runs on the same port configured in the storm.yaml before. To start the UI, use the same storm command with the argument UI. It may take a few seconds for the topology to start. The UI is set to start here. Once it's started, we can open the Storm UI on any browser at the specified port. So now that it has started, let's open a browser and go to the port number 8080. The Storm UI provides a summary of cluster, and we can view all the previous running topologies and their configurations. We can also see the Nimbus configurations listed here. We can now view one of the topology which was run earlier. It also gives a UI, mention how long it has been running, what is the status as of now, and also provides options to terminate, activate, kill the topology from the UI. We can also see the number of spouts and bolts configured for this topology. And it also provides a topology visualization tool where we can actually see how spouts and bolts are connected. In this example, we can see that there is one spout connected to a split bolt, and the split bolt is in turn connected to a count bolt. It also has information about the topology configuration, which is also available in the YAML file seen before. We can also look in detail of any of those specific bolts or spouts. Here we are taking a look at the spout. We can also see the number of executors which was active during the topology execution. This is same as what we had configured in the storm.yml file. Now that we have seen how to start the topology and navigate the UI, let's dive into the demo of viewing top-end tweets. The first thing we need to do is create a Java file where we design the topology. We use the topology builder for this purpose provided by the Storm. Since we are going to use Twitter, we need also the Twitter authentication to be provided in the code. So once that's done, let's see how we can create spouts and bolts and connect the topology. We can see that we have a single spout called tweet spout, which is connected to the Twitter spout. We are also using a set of bolts The first bolt which we connect this bolt to is called parse tweet bolt. It is connected using shuffle grouping on the tweet spout keyword with a parallelism of 10. This indicates number of tasks which run inside the bolt. The parse tweet bolt is in turn connected to another bolt called count bolt via fields grouping on the field tweet word. So all these bolts are in turn classes. The highlighted bolts are a set of open source bolts provided by the Storm team. One of it is intermediate rankings bolt, which is connected via fields grouping on the field word coming from the count bolt. And the other one is total rankings bolt, which is connected via global grouping on the intermediate ranker bolt. The final bolt is the report bolt, which is connected via global grouping on the total ranker bolt to give us the final top and trending words. All these bolts are intern classes where we define the functionality of what to do with the tuple and how to emit the tuple. We'll look at one of the bolts, parse tweet bolt, in detail now. Let's see how we can create a new bolt. Here we are creating a bolt, parse tweet bolt, which is extending the base rich bolt provided by the Storm. The functionality of this bolt is to prevent stop words or skip words from getting counted. It has methods such as prepare, execute, and declare output fields. The declare output fields method specify the name of the field on which the tuple will be emitted on. So here in this case it's tweet word. The execute method is used to specify the functionality of how to process the input tuple and emit. Here we can see we are using the collector.emit function to emit a value. The tweet word is the same field name on which the fields grouping is done in the count bolt. Similarly, we have functionalities defined for each of the classes of the bolts. So now that we have seen in code how to create the topology, let's see how we can feed that into the Nimbus. The first thing we need to do is create a package. We can use mvn package command to create the jar file. It may take a while for the package to complete, pulling all the dependencies. Once it's done, it will create a snapshot jar with dependencies.jar file, which we can feed into the Nimbus. The Nimbus will then take care to distribute among its supervisor nodes. Remember, no code is executed in Nimbus. So let's wait for the build process to complete, and then we can look at how we can feed this data into the Nimbus. So now that the process is completed, we can use the Storm's jar command and specify the jar which was created along with the base class where the topology is designed. So this way we can feed the data jar into the Nimbus, and the Storm topology is started now. We also have a simple web server which is connected to the Storm in the backend to visualize the top trending tweets in real time. As the Storm continues to run, the web page will be able to show you the top trending words in real time, increasing in size depending on their count.